Okay, so in this video we're going to talk about properties of limits. So suppose we know three things. First, k is some constant, and the limit as x goes to c of f of x is some number L, so the limit exists, and the limit as x goes to c of g of x is some other number m. All right, so if we have these three things, then we're going to have 6 properties. The first is the limit of the product of f and g is going to be the product of the limits which is just L times M. Okay, secondly, we're going to have the limit as x goes to c of f of x plus or minus g of x. And that's going to be what you think. It's going to be the limit as x goes to c of f of x plus or minus the limit as x goes to c of g of x, which again is L and M, so L plus or minus M. Third property is the limit of a quotient. All of these properties are intuitive. So this is going to be the quotient of the limits, like so, which is just L over M. Fourth property, the limit of a root, nth root of f of x is going to be the nth root of the limit of f of x, which is the nth root of L. And then we have 2 more properties which are just really almost trivial properties. The first is the limit of a constant is just the constant, and the limit as x goes to c of x is c. All right, so let's combine these properties of limits in an example problem. So let's say we have the following. Say we want to find the limit as x goes to 2 of x times f of x minus g of x all over the square root of g of x, provided we know that as x goes to 2, f of x goes to 3, and as x goes to 2, g of x goes to 4. All right, so first thing we note is that this is a quotient. So the limit of a quotient is the quotient of limits. So this limit as x goes to 2 is of this quotient is going to be the limit of the denominator, limit of the numerator, excuse me, over the limit of the denominator, like so. And then we can start going through other properties. So we have a limit of a difference here. So this is going to be a difference of the limits. This takes a little bit of work to write out, but we'll do the work so you can see why it's true. At the bottom we have the limit of a root of g of x. So that's going to be a root of the limit of g of x. And on the top we have, the only thing left to do is we have this product. So this is going to be the product of the limit of x and the limit of f of x. And now we can just use what we're given. We know what the limit of g is and the limit of f is. And we know by our very last property of limits that x goes to 2. So we'll have the limit as x goes to 2 of x is 2. F is 3, going to 3, g is 4, and then we have in the bottom the square root of 4. And this works out to 6 minus 4 over 2, which is 2 over 2, which is 1. Okay, so you can see that these limit properties allow us to compute the limits of complicated compositions or combinations of functions where we know the limits of those functions. So the main thing that we apply these properties of limits to is polynomials and rational functions. So we want to evaluate the limits of polynomials and rational functions. You should think of rational functions as ratios of polynomials. So to do this, we're going to use a set of rules. So the first rule is if f of x is a polynomial, i.e. it's of the form a0 plus a1x plus dot 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 an x to the n. Sorry, my handwriting is not great here. So essentially powers of x with coefficients and then summed up. Then the limit as x goes to c of f of x is f of c. In other words, this function is continuous. All right, secondly, if f of x is a rational function, a ratio of polynomials, so it's of the form p of x over q of x, where p and q are polynomials, then the limit as x goes to c of f of x is p of c over q of c, provided q of c is not equal to 0, because we can't divide by 0. Now, if q is 0, if q of c is 0, then we consider the numerator p of x evaluated at c, so p of c. Now, if p of c is 0, then we're going to factor x minus c from both q of x and p of x and reduce and take the limit. And if p of c is not equal to 0, then the function f of x does not have a limit. So say it this way: the limit as x goes to c of f of x dne does not exist. Okay, so this is a complicated set of rules. Let's do a couple examples. The first example here is going to be a polynomial. We're going to take the limit as x goes to 2 of x squared minus 4x plus 5. And you'll see here the first rule is if we have a polynomial, then wherever x goes to, that c value, you just put the c value into the polynomial. So this is going to be 2 squared minus 4 times 2 plus 5. So 4 minus 8 plus 5, which is 1. All right, let's do another example. This will be a rational function, a little more complicated. So we're going to have x squared minus 5x plus 6 over x squared minus 4. So first thing we're going to do is we're going to put c, the 2, into the numerator polynomial and the denominator polynomial. See what happens. So we'll get 2 squared minus 5 times 2 plus 6 over 2 squared minus 4. So this will be 4 minus 10 plus 6 over 4 minus 4. So this is 0 over 0. This is indeterminate. Okay? So if the numerator is 0 and the denominator is 0, then we're going to factor x minus c from the numerator and denominator polynomials. Okay, so we're going to take this and we're going to factor the numerator and denominator. We know that they factor because 2 is a 0 of both. And we'll get x minus 2 times x minus 3 and x minus 2 times x plus 2. The x minus 2's cancel. We can reduce. And then we'll have something we can put 2 into again. And hopefully this time we'll get something that's not indeterminate, not 0 over 0. We get negative 1 over 4. Okay, so that's nice. Again, if the numerator and denominator polynomials are both 0, then we can do this factoring. Now, if the numerator and denominator polynomials are not both 0, then we might have a problem. So let's do an example like that. So here, if I plug 1 into the numerator polynomial, I get 1 squared minus 2 times 1. That's negative 1. If I plug 1 into the denominator, I get 0. So I get negative 1 over 0. And that is not existing, right? So going back to our rule here, the numerator polynomial, the p of c, is not equal to 0, but the q of c equals 0. Okay, and that's essentially what's happening to this rational function is it's blowing up. It's 1 over something that's going to 0, negative 1 over something that's going to 0, so that's blowing up. So this is DNE. All right, one more example. Let's take the limit as x goes to 2 of x squared minus 4x plus 6 over x plus 2. Just plug 2 everywhere. And we get, well, we get something that's nice. 4 minus 8 plus 6 over 4 is 2 over 4, which is 1/2. All right, so that's it for properties of limits. I hope you found this video useful.